All right, so this is a video signature assignment for the soap project. I'm Jaiden. We also have Sebastian, Adriana, Ian, Noah, and Alex. All right, so to go over the goals for our soap project, to start off, the overall goals was to design, implement, and analyze a study exploring the effect on the yield and quality of soap due to the conditions of a reaction. We also wanted to identify trends in our data to make a recommendation for the best conditions to optimize both the yield and quality of the desired property. And lastly, to basically succeed in this, we had to confirm the target product was produced and evaluate its quality by designing and conducting characterization tests. So in that first session, the goal was that idea of conducting the soap synthesis and isolation using a non-optimized procedure and exploring those trends to recommend the best conditions to optimize both the soap yield and quality. Then in the second session, we wanted to identify those trends, the positive and negative controls to be used to test the quality of the derived soaps, calculating the percent yields for all of the soaps, which led into our final session, which was the idea of performing the design test to characterize the soaps we created.
The independent variable was changing the oils we used to create the soap. The dependent variables then were the amount of soap we made, the percentage yield, pH, and the amount of bubbles generated from the agitation. We used these variables in our soap testing procedures. Our positive controls were the ivory soap, and the negative controls was deionized water. That's essentially our zero. The reason we changed the oils was because those would polarize the resulting soaps more than any of the other variables. And the reason we chose to test pH and the volume of bubbles is because they're both quantitatively measurable.
So for our procedure in creating the soap, we set up a hot plate stir and prepared a hot water bath of deionized water. Then we placed a thermometer within the water and we brought and managed the heat to 90 degrees Celsius. We weighed out our variable oils and placed it into a centrifuge tube. Then we added 3 milliliters of 3.0 molar KOH and 3 milliliters of ethanol, as well as a magnetic stirring stick into the centrifuge tube. Then we placed the bottom of the centrifuge tube into the hot water bath, making sure that it didn't touch the sides or the bottom of our bath. Then we stirred and heated it on high for 15 minutes. Then we prepared an ice bath and chilled the mixture. And then we also chilled 50 milliliters of KOH and 20 milliliters of DI water. Then when it was chilled, we added the KOH to the mixture and let the solution sit in the ice bath until it chilled. Then we agitated it semi-frequently to generate more soap crystals. Using a filter flask, we filtered out any leftover liquid out of the precipitate or our soap using the DI water. Then we collected the remaining soap and then we weighed it to calculate our percentage yield.
The percentage yield is calculated by dividing the actual yield by the theoretical yield. And for all the calculations, the theoretical yield was 2.06 grams. The percentage yield of all the gathered soaps were as follows. The coconut oil had an actual yield of 23.28 grams, making the percentage yield 1,128%. The palm oil had an actual yield of 5.141 grams, making the percentage yield 248%. The canola oil had an actual yield of 3.015 grams, making the percentage yield 146%, and the soybean oil had an actual yield of 5.551 grams, making the percentage yield 270%. This data indicates our procedure worked and that the coconut oil produces more product than the other tested oils by a wide margin.
Now we have the procedure for the soap testing. And we have on the left side the pH quantitative test, and on the right side we have the bubble quantitative test. Starting with the pH quantitative test, we first weighed out 1 gram of each soap and ivory soap, which was the control, into 20 milliliter vials. We then put 3 milliliter of nanopure water into each vial, and we were shaking it slightly. We then used a pH testing strip to estimate the pH of each soap by the color of the strip. Now moving on to the bubble quantitative test, we first used the soaps created, then weighed out 0.75 grams of each soap. We put each soap into a centrifuge along with 3 milliliters of deionized water. We then measured the amount of liquid into the vial in milliliters. After that, we were shaking it vigorously for about 10 seconds. Then lastly, we waited for the suds to settle. Then we measured the increase in milliliters.
Moving on to our results, you can see that coconut oil soap had a pH of 7.5, whereas the palm oil had a pH of 8, as did the soybean, canola, and ivory soap samples. Our controls, which were deionized water and sodium hydroxide, showed the correct pH, so the results for the soap are most likely accurate. Moving on to the bubble test, coconut oil produced 1.55 milliliters of bubbles. This was calculated by measuring the amount of soap with water and then subtracting that from the final bubble level. In this example, it is 4.25 milliliters minus 2.7 milliliters for coconut oil. Palm oil produced 2.3 milliliters of bubbles, soybean oil produced 3, canola produced 1.9, and lastly, the ivory soap produced 5.75 milliliters of bubbles. The deionized water obviously produced 0 milliliters. Using these metrics, primarily judging by the volume of suds, Ian's soybean soap was the most effective of the synthesized soaps. Now, moving on to the graphs, the pH shown is fairly constant across all of the oils. And in the bubble test, it can be seen that the ivory soap produced substantially more bubbles than the synthetic ones. However, soybean was the highest of those.
Analyzing the results from our pH testing showed that the pH values of all 4 soaps created were nearly the same as the pH of our positive control ivory soap, which was 8. As for our soaps, the palm, soybean, and canola oil-based soaps all had pH values of 8, while the coconut oil-based soap had a pH of approximately 7.5. Comparing these results to our negative controls, we see that the pH value of the 4 soaps were below the pH value of NaOH, but above the pH values of the oils themselves. The palm, coconut, soybean, and canola oils all had a pH value of 6. Based on these results, we can conclude that the quality of our soaps was very similar to the quality of the ivory soap, which was our goal. Analyzing the bubble test, it demonstrated that the characteristics of our soaps compared to the characteristics of the ivory soap were similar but not exact. Through our testing, we found that mixing the oil-based soaps with deionized water created a smaller volume of bubbles compared to when we mixed the ivory soap with the deionized water. This could mean that our soaps might not have the exact characteristics as the ivory soap. However, the amount of bubbles produced shows that our products had definitive soap characteristics.